see how we can use the cases which involves, we are still under the trapezium rule. Trapezium rule, now we are looking at the cases which involves getting the error. Because when you use this method of the trapezium rule to integrate or to evaluate this one, you get it with some magnitude of the errors. Then how do you get the error which is made? You get by getting the exact value. And getting the exact value, we use the method of the calculus. The method which we use in pure mathematics in integrating, the value which we get is the exact value. Then the value which we get using the trapezium rule with specified number of ordinates, like here we're using 6 ordinates. The value which we get, it is the inexact value. So remember, we said that the error is equal to the exact value minus the inexact value. So when we get the inexact value by using the trapezium rule, then we get the exact value by using calculus, then we can get the error which is made in our evaluation. So let us start by seeing how we can use the trapezium rule to integrate that one. So we say that if you integrate from a up to b a function of x, f of x dx, it is h over 2 into y naught plus yn plus 2 into y1 plus yn minus 1. And that is the formula which we are using to integrate. So when we try to compare, here we are having the integrating this one here. Our upper limit is 2, our lower limit. So first start by getting the value of h, which is b minus a over n. And they have told us, they have given us the information that we are using 6 coordinates. And if you're using 6 coordinates, it means that the number of sub-intervals are 5. Number of sub-intervals are 5. Number of sub-coordinates is 6. Sub-intervals or sweeps are 5. So here we are having the upper limit 2 minus 0 over 5. And this one is giving us 0.4. So we come to our y. Our y is this one, which is y equals 1 plus cos of x. And then we get values of x, and we get their corresponding values of y. Get their corresponding values of y. So we start with the lower limit. The lower limit is 0. Then is 0 plus h plus 0. Then here it will be h plus 0, you have 0.4 plus h there, gives us 0.8 plus h, gives us 1.2 plus h here, which gives us 1.6, then plus h, which gives us 2.0. So here we get the calculators. Here this is the y. We get the 0 and substitute here. When you substitute the 0 here, when you go plus 1, then you get the answer here. Then you go to substitute, remember there is an x to 0.4 plus 1, you get the answer. Substitute 0.8 here, but make sure that the calculator has been set to radians because there is a trigonometric function. So this one here, it is an inexact method of evaluation, of integrating. Then we shall, after getting the answer, we shall see how we can get down the exact value. Then we compare the two to get the errors which are required. So if we are using now our calculators here, but strictly the calculator should be set to radians. When you substitute the 0 here, you get this. Substitute the 0.4, wherever there is x, you get that. Substitute the 0.8 here, you get that. And then you, this is how now the table is supposed to appear. Now the first value is our y naught. The last value here, which corresponds to the upper limit 2, is the yn. Yn. So these ones here, the ones which are very important, y naught and yn. The last one is yn, the first one is y naught. All these arrows in the middle there, they are multiplied by 2 according to the formula. It is not a y naught and yn, which is not multiplied by 2. So we come and get now, when we integrate from 0 up to 2, 1 plus cos of x dx. This one will give us, get our h. We have already obtained the value of h, which is 0.4 over 2 into, now the yn, it is 2. The yn it is 0.5839 plus y naught, which is 2.0000. Measure, minimize, maximize the number of decimal places for accuracy purposes. Then plus 2. All these other ones are multiplied by 211 plus 1.6967 plus 31.3624 plus 0.9708. And then all these ones are multiplied. So now we use the calculator comfortably and get the value. So after using our calculator here, after using the calculator, substituting all these values, but what you cannot forget, apart from the yn and y naught, those are ones are not multiplied by 2, but all these other ones, you add this one, and this one, and this one, and that one, then you multiply them by 2, you get this. So when you add this one, is the result of this one is the result of this bracket here. So when you add 0.45 by 2, so when you compute, don't forget to follow the instruction. It said that you should correct the answer to 3 decimal places. So here you value using 10 decimal places, 12 decimal places, as long as you use a minimum of 4 decimal places for actual decimal places. In the answer when you're giving the final answer, you follow the principle. You follow the instruction that you should give the answer to 3 decimal places. But if the question was open and the one has to evaluate using the Trapezium rule, then you give 4 decimal places for accuracy purposes. But you can give 3 decimal places according to the instruction there. So this is what we get after evaluating and using the Trapezium rule. That is part 1 of the question. This is part 1. Then part 2 of the question, they are saying we should find the exact value. Find the exact value of 0 to 2, 1 plus cos x dx. This one here we integrate using the principles of calculus. And when you integrate 1 here, we get x. When we integrate cos, we get sine. Then we are integrating from 0 up to 2. When you integrate 1, you get x. Integrate cos, you get sine x. So what we do, we substitute in the limits. So the integral from 0 up to 2 into 1 plus cos of x dx. This one here will give us, substitute the upper limit first. It will be wherever it is x, we put into, so it will have 2 plus sine of 2. And then that is the upper limit minus the lower limit. So wherever there is a lower limit, wherever there is x, put the lower limit, so it will be minus 0 plus sine of 0. Then we see what we get there. So when we substitute, be very careful here when we are substituting. Wherever it is 2 put x, wherever the x put 2, wherever the x, then we create a bracket for the upper limit, also create a bracket for the lower limit. So after substituting the limits, we get our exact value as 2.9093. So, since the question is instructing us to get the error which was made, so when you use the method of calculus, you obtain the exact value. When you use the Trapezium rule, this is the inexact value, this is the exact value. So to find the error equals the magnitude of the exact value minus the inexact value. So here we get the values, the exact value which is 2.9093 minus the inexact value which is 2.897. Then what we get there. So this is how we obtain the exact value minus the inexact value. The exact value is the value which you get using calculus, the inexact value when we're using the Trapezium rule. So these magnitudes you include them there, such that even when you subtract these two values and get a negative, you present it as a positive. You want the absolute value, not in the sign. That's why when you are writing the formula for the error, you put these magnitudes to such that, for example, if we obtain like a negative 1 inside here, you present it as 1. Once you are interested in the absolute value, that is the meaning of these magnitudes. So when you're stating your formula of the errors, include the magnitudes. So when you subtract the exact value minus the inexact value, you get the error which is committed there. If the question requires us to get the relative error, by definition, the relative error is equal to the absolute error over the inexact value. So here, inexact value, or you find when it's are using, it is the relative error is equal to absolute error over the exact value. Both of those will give you the same answers. Absolute error over the exact value. When you take this, if you use this one or use this one, you still come up with the same answer. So don't get confused and say, now we're using inexact here, exactly, you still come up with the same answers. At the level of accuracy for these two places, the answers will be the same. So when we use absolute error over the inexact value, so meaning that the relative error here is for the absolute error. It is the exact value minus the inexact value, and everything is over the inexact value. So this one here we already obtained. This one here, the difference between the exact value and the inexact value, it is the absolute error. Then over the inexact value. So the relative error there will give us the exact value, which is according to our computations here. The exact value, it is 2.9093, and the approximated value, that is the inexact value, is 2.897. So since you have already obtained the difference between the exact value and the inexact value, you just substitute, which is 0.0123, then divide by the inexact value, which is 2.897. And this one gives us here, you will come up with the 0.0042. Even when you use the exact value at the level of accuracy for the small places, you have the same error. So both of the formula ones, exact value over the exact value over the exact value, you still come up with the same answers. So the percentage error here, the percentage error here will be equal to the relative error times 100%. So this one here will have 0.0042 times 100%. So this one here will give us the 4.2% error. So that's how we will obtain the percentage error. The percentage error is equal to the relative error times 100%. So if the question wants us to get the relative error, you will come up with the first get the relative error, which is absolute error, absolute exact minus exact over. Then the percentage error is the relative error. So means that the whole of this term here times 100% gives the relative error. So our relative error is 0.042 times 100. And this one here is giving us 0.42%. So that is the error which is committed when we are using 6 coordinates or 5 scripts to interpret using the Trapezium rule. And how to minimize the error which is made there, how to minimize error, how to make the error very, very small. First of all, increase the number of sub-intervals. In bracket or scripts. Use it. That is using a bigger value. n. That is using increasing the number of intervals or using the number, increasing the number of strips. That means if you increase the number of strips, there is increasing the value of n. That one minimizes the error between the exact and the inexact value. So the other way is increasing the number of decimal places. Decimal places are used in the steps of evaluation. So that's why we are insisting that in your table in those steps, you try to maximize the number of decimal places. So the more number of decimal places which you use in every steps when you are calculating, you are reducing the error, the error between the exact and the inexact value. So the more number of scripts used reduces the error. The more number of decimal places used in your table during the computation, the less value of the error you commit during the evaluation. So that's one of the sample questions which can be used, which involves the trapezium rule and the errors